Today we're going to talk about Pythagorean Theorem. It's something you've seen before. What is the Pythagorean Theorem?
A squared plus B squared.
A squared plus B squared equals C squared. You know that. That's nothing new. Okay? We're going to look at some little shortcutty ways to do it today. So that'll be kind of nice. When I look at this picture right here, I know that A squared plus B squared equals C squared. And this only works in what type of a triangle? A right triangle. Remember, everything we're doing this unit is all right triangles. This unit and the next unit will all be right triangles. Where my legs are my A and my B, and my C is my hypotenuse. Okay? If I were to kind of rework the formula then, instead of A squared plus B squared, I would say it's one of the legs squared plus the other leg squared is going to give me my hypotenuse squared. Okay, so I'm going to kind of think of it more along those lines. A leg squared plus a leg squared gives me my hypotenuse squared. That way we don't have to worry about which one are we using, A or B. Okay? We have two situations that are going to arise. We're either going to be looking for a hypotenuse or we're going to be looking for a leg. We're never going to be looking for both at the same time. Okay? So if I want to find the hypotenuse, I need to solve the equation that I just wrote for the hypotenuse. And I almost have hypotenuse right here. But it's not just the hypotenuse. I have the hypotenuse squared. I need to get rid of this square right here. How do I get rid of a square? I do what? I square root it, right? The opposite of squaring is square rooting. If I square root this side so that I cancel these two out, I also have to square root the other side. You can't just square root one side. Okay? So what I end up with is the square root of a leg squared plus another leg squared, and that's a plus, equals just a plain old hypotenuse. It's no longer squared because we unsquared it when we square rooted. So the answer is not going to have a square on it. It's just the hypotenuse. Okay? That's kind of going to be my new formula for if I need to find a hypotenuse. Okay? To find a missing leg, then I want to solve for one of the legs. It doesn't matter which leg. I have two legs in my equation. To get rid of one of them, if they're being added together, how do I get rid of one? Subtract it. So if I subtract a leg squared on both sides, minus a leg squared, minus a leg squared, okay, then one set of leg squareds cancels out. So I end up with leg squared equals, and I can't combine hypotenuse squared and leg squared, so I just write it out the way it is. Hypotenuse squared minus a leg squared. Okay? So I'm almost there, but I don't want the leg squared. I want just the leg. How do I get rid of the square on that leg? I square root it, right? So if I square root both sides, then on this side, my square root and my square cancel out. They go away. I just have a leg on the left-hand side. That equals the square root of the hypotenuse squared minus the leg squared. So if I look at those two formulas, they're very similar. I have the square root of something squared and something squared. The only difference is what?
It's subtracting instead of adding.
One is adding and one is subtracting. It's both the square root of something and then either plus or minus the square of something else. Okay? If I'm looking for a hypotenuse, it's always going to be adding. If I'm looking for a leg, it's always going to be subtracting. So the first question I'm going to ask you every single time is, am I looking for a leg or am I looking for a hypotenuse? Because that's going to tell me what to do inside my square root. Okay? So let's look at these two examples. If I look at the first one, if you have, does anybody have a hard time finding the hypotenuse? Anybody? No, we're all good. We're all great at it. If anybody does, it's just right across the triangle from the right angle, okay? So when I look at this, I can see that I am missing the hypotenuse, which means if I'm missing my hypotenuse, I am going to add inside my square root, okay? So I'm going to add inside my square root. So the first thing I always do is I draw my square root, and then I'm going to add. Then I put my two numbers in, and they do have to be squared, okay? You don't have to square them before you put them in. You can just write them squared. 5 and 12 are interchangeable. I will tell you I almost always will put the bigger number in first because it doesn't matter on this side, but on the next side it will. And just so I never have a problem, I always put the bigger number in first. So I'm going to do 12 squared plus 5 squared. Okay? All right, so let's type that in the calculator. The square root of 12 squared plus 5 squared. Make sure the whole thing stays under the square root bar. You get what? 13. Beautiful.
You don't square that.
You don't square that. Remember, because when you square root, that's unsquaring it. Okay? So it's just 13. That's a real common mistake I see. People put a little square on it. You don't. It's just the 13. Okay? Or if it's units, they'll write out the units like centimeters, and then they'll put a square on it, and that's wrong. It's not squared. Okay? All right, so then when I look at the next one, yes?
That's not the same as 17 squared. As 17 squared, right?
No, it is not. It is not the same thing as 17 squared.
And then that's right.
No, that doesn't work. Good question. Okay, for the next one, again, if I look across from my right angle to see where my hypotenuse is, I see I'm not looking for my hypotenuse, I'm looking for a leg, which means this time inside my square root, instead of adding, I'm going to subtract. Okay? All right, so when I do this, again, you must put the bigger number in first. So I'm going to put my 15 in first, and then my 9 in second. Don't forget to square them. So then in my calculator, I'm going to do the square root of 15 squared minus 9 squared to get my answer, which is 12. Very good. Just a plain old squared, not anything. Yes?
The hypotenuse is bigger than the side.
Yes, you can check your answer because if you get something bigger, you did something wrong because the hypotenuse is always your biggest answer. That's a good thing to look at, okay? You'll notice if you do put this one backwards in the calculator, it's going to pop up with an error message that says that is not a real answer, okay? So it'll tell you. You'll know if you put it in backwards because the calculator won't give you an answer. And then when you click out of that message, it'll even say error, not real answer, okay? And you'll be like, oh, what did I do? You just put them in backwards, okay? Let's look at the next two examples. Okay? When I look at the first one, my 8, my x, and my 6, am I looking for a hypotenuse or am I looking for a leg? I'm looking for a hypotenuse. So inside my square root, am I going to add or subtract? I'm going to add. And then I almost always put the bigger number in first just so I stay safe. So I'm going to put 8 squared plus 6 squared. And when I type that in my calculator, what do I get for my answer? 10. Now, so far, we've always gotten whole numbers. Do you think you always get whole numbers?
No.
No, it's okay to get a decimal. If you get a decimal, don't panic, don't freak out, you're okay. All right, look at the next one. Am I missing a hypotenuse or a leg? I'm missing a leg, so in my square root, what am I going to do? Subtract. Make sure we put the bigger one in first, so I'm going to do 17 squared minus 8 squared. 17 squared minus 8 squared gives me 15. Okay. All right, next. More practice, yay! All right. Looking at the next one, technically I can't do the next one. Why? Because Miss Bishop forgot to put the right angle in it, and we're not supposed to tell by looking, okay? So if this did have a right angle right here, what would x be? Okay? Hold on, you're spoiling my fun if you already answer. Okay, so when I do my square root, I need to decide a plus or a minus. Minus, because I'm looking for a leg. 34 squared and 16 squared. All right, now you can give me my answer. What is it? 30. Okay. All right, when I look at example 2 over here, inside my square root, am I going to put a plus or a minus? A plus, because I'm looking for my hypotenuse. So 36 squared and 15 squared. What do I get for my answer?
39.
39?
Yeah. It's pretty easy.
Very good. Yeah, pretty easy, right? All right, sometimes we have application problems. That's just a fancy word for word problem, okay? All right, so here's our first application problem. Find the hypotenuse of a right triangle with legs that measure 8 and 11. What should I do first? Draw a picture. Okay, so what type of triangle should I draw? A right triangle. So I'm going to make it as right as possible. I mean, I'm only human. That's not very pretty, but pretend it is. Okay. All right, so find the hypotenuse. I'm going to put my X on the hypotenuse of a right triangle with legs that measure 8 and 11. All right, so in my square root, what do I want? A plus or a minus?
Plus.
A plus. And my two numbers are 11 and 8. Let's round to 3 decimal places. What do we get? What do I get? 13.602 when we round correctly. Okay. All right, let's look at the next example. A 15-foot ladder is resting against a home. The base of the ladder is 6 feet from the home. How far off the ground is the ladder? What should I do? Draw a picture. So you can get as fancy or as not fancy as you want with these. So I've got a house. That's my really, really tall house. Okay. And then leaning up against the house is a ladder. Now, I know in life we say you're never allowed to assume anything, but in geometry we're allowed to assume that things are made architecturally correct, which means we're allowed to assume that buildings stand perpendicular to the ground. We're allowed to assume that things like flagpoles and telephone poles are perpendicular to the ground unless we're told otherwise. All right? So I'm allowed to assume that the house is perpendicular to the ground in geometry. Okay? All right, now what I'm going to do is I'm just going to label the right triangle that I see with an A and a B and a C so we can make sure we get everything in the right spot. A 15-foot ladder is resting against a home. Which one is the 15, A, B, or C?
C.
C, because that's the length of the ladder. The base of the ladder is 6 feet from the home. Where does that go? That goes in B. So that means I'm trying to find A. When I do my square root, am I going to get a plus or a minus?
Minus.
A minus, because that's a leg. Which one goes in first? Why? Because it's bigger, so 15 squared. And 6 squared. I'm going to get a decimal. Let's round it to 3 places. How far off the ground are we? 13.748. I have units on this problem. What are my units?
Feet.
Feet. Okay, so if I've got a little person standing up here at the very top of my ladder, they are 13.748, almost 14 feet off the ground. Okay? All right, the next, I need everybody to watch this one. This one, you will have a problem like this one on the test that's coming up. You will have a problem like this on the test. This one, unfortunately, we cannot use our shortcut. We have to go back to a squared plus b squared equals c squared. Okay? You'll see why in a minute. This one, there will be one like this on the test. Okay? So make sure you're paying attention. It says the length of a longer leg of a right triangle is twice as long as the length of the other leg. If the length of the hypotenuse is 60, find the length of the shorter leg. What's the first thing I should do? Draw a picture. Now, it's a right triangle where I know I'm going to have one leg longer than the other. So it doesn't matter if you draw it laying down like this, like I am, or if you draw it nice and tall. It doesn't matter. Okay? It says the length of the longer leg is twice the other leg. So if I call the shorter leg X, how long is the longer leg if it's twice as long? 2x. Very good. And then the length of the hypotenuse is 60. Okay, so since I have two unknowns, it's hard for me to say, oh, I'm going to do a plus or a minus inside the square root because I don't have two numbers to put inside the square root. Okay, so that's why we have to go back to our regular old a squared plus b squared equals c squared. Okay, now when you're doing a squared, that's the leg times itself. Or b squared, it's the leg times itself. So when I look at the leg here, my short leg, when I multiply x to itself and I do x times x, I end up with x squared. Okay? When I look at the other leg, 2x, and I square it, what do I get? What do I get? 4x squared. Very good. This is where a lot of people tend to go wrong, okay? Because remember, you're squaring also the 2. A lot of people will just put a 2x squared. But it's 2x times 2x, so we end up with 4x squared here. Okay? And that equals c squared, which is 60 squared. All right. Anybody know what we do next? Yes. Simplify, right? We're going to combine our like terms. I have 1x squared plus a 4x squared. How many total x squareds do I have? I have 5x squareds. Let's go ahead and actually, what is 60 squared? 3,600. All right, next, what do I do? Divide both sides by 5. X squared equals 3,600 divided by 5? 720. Okay, and then the last thing, square root. And what does x equal? 3 decimal places. 26 point what? 833. Now, did I answer my question? No? My question said to find the length of the shorter leg. That's my shorter leg. Did I find it?
Yes.
Oh, I did. This is my answer. So, yay. Now, if it said find the length of the longer leg, would I be done?
No.
What would I still need to do? I'd need to multiply that by 2. Okay? All right. Next, using Pythagorean theorem in an isosceles triangle. What type of triangle? Isosceles. Now, here's the nice thing about isosceles triangles that we need to remember. Our altitude in an isosceles triangle does something to the base. Do you remember what? Divides it in half. Okay, so I know these two pieces are the same. So if that whole bottom is 8, each side is 4. But I said we're working with what type of triangles this 6 weeks?
Right.
Right triangles, not isosceles triangles. So I need to look at just the right triangle portion of the isosceles triangle. If I look at just that shaded in part that I just shaded in, okay, then, and if you want, you can redraw it off to the side. Sometimes that's helpful for us that need some spatial help. Because then all of a sudden it kind of declutters what I'm working with. On my square root, what am I looking for? A leg or a hypotenuse?
Leg.
Add or subtract? Subtract, because it's a leg I'm trying to find. Which one goes in first? 9 squared, and then 4 squared. Round to 3 decimal places, the square root of 9 squared minus 4 squared.
8.062.
8.062. Easy peasy? All right, let's do one more of these. Okay, I've got another one. This time, I'm looking for, again, I'm still looking for the altitude, which I know does what to the base? Cuts it in half, so each side is 9, but we're not supposed to be working with isosceles triangles. We're supposed to be working with right triangles, so I'm just going to look at one side. And again, if you want to redraw it, you can. It looks like this, with a 9 here, a 26 here, and an X here. Am I looking for a leg or a hypotenuse? A leg, so add or subtract? Subtract. Which one goes in first? 26 squared, 9 squared. So in my calculator, the square root of 26 squared minus 9 squared is? 24.39, what? 3. Yes. Okay. Now I have an application problem, just a fancy word for word problem. Okay. The length of the legs of an isosceles triangle with an altitude of 30 centimeters and a base of 20 centimeters. So I want to find the legs this time. Last time I was trying to find the altitude. What's the first thing I should do?
Draw a picture.
Draw a picture of what kind of triangle? Isosceles. So that means two sides are the same. I could even draw congruent base angles if I wanted, just because I know that happens in an isosceles triangle. Find the length of the legs. So I'm trying to find these two things. Okay, I know they're the same because they're the legs. And my altitude is 30 centimeters. So from the vertex angle straight to the other side at a 90-degree angle, that is 30 centimeters. And my base length is 20 centimeters. All right, what should I do first? Divide the 20 into 2 equal parts, so each side is 10. And then instead of looking at the whole triangle, I'm just going to look at one side of it, right? And again, if you want, you could redraw it. So I'm looking for X. I've got a 30 here and a 10 here, and my right angle's right there. In my square root, add or subtract? Add. Why? We're looking for the hypotenuse. Which one am I going to put in first? 30, and I'm going to square it, and then 10, and I'm going to square it. So when I round to 3 decimal places, the square root of 30 squared plus 10 squared gives me? 31.623. What are my units here? I know my units. Centimeters. And remember, it's not like centimeters squared or anything. It's just plain old everyday centimeters. Okay? All right. Multi-step. Yay! We love multi-steps. All right. I want to find X. X belongs to this right triangle right here. But I can't find it. Why? Because I need to know what this side is in order to know what X is, yes? Okay, so look at the next right triangle. This blue one. If I want to find this piece here, can I find it? Why not? Oh, because I don't know how long this one is. All right, well then look at this triangle. Can I find the green piece on this triangle? Yes. Yes. Is that green piece a leg or a hypotenuse? Of the green triangle, it's a what? It's a leg, right? Because if I go across from here, my hypotenuse is the 26. So am I going to add or subtract? I'm going to subtract. Which one goes in first? 26 squared. And what's my second number? 24 squared. What is the square root of 26 squared minus 24 squared? 10. But that's not my answer. That's just how long that piece is. Okay? So now if I come back to my blue triangle, I can find the missing side of my blue triangle. Is that missing side on the blue triangle a leg or a hypotenuse? A leg, so am I going to add or subtract? Subtract. Which one goes in first? 10 squared minus what else? 6 squared. Square root of 10 squared minus 6 squared is? What? 8. Okay. All right, so now I know this piece right here is 8. Now, do I have enough information to find the hypotenuse of the red triangle? Yes. Am I going to add or subtract? Add, because I'm looking for a hypotenuse. Which one goes in first? 8 squared, and then 3 squared, and then round that to 3 decimal places. What do I get? 8.544. Do I have any units? No, I don't, so I'll just leave it like that. Okay? Multi-step. Woohoo! Good times. One more. You excited? All right, during a severe thunderstorm, a utility pole was struck by lightning, and a portion of the pole fell over as shown below. Find the height of the utility pole before it was damaged in the storm. So originally, my pole was standing nice and pretty and tall. But there was a storm, and so it fell over. I want to know, how tall was it originally? What was this original length? Okay, that's what it's asking me. Okay? What do I need to do? Yeah, I need to find the part of the pole that fell over, right? I need to find this part. Is that a hypotenuse or a leg? So add or subtract. What number goes in first? How much of the pole fell over? 10. So that means this part of the pole was 10. How tall was the whole pole? The original height was 16. What are my units? Feet. Just plain old feet.
Would they ever be really mean and have us convert from like a bunch of different things into the right thing?
Possibly. I don't think anything I'm going to give you does. But yeah, you do want to keep in mind that sometimes you might need to convert. That's a good question. All right. The next one isn't really a problem. It's just one kind of neat little look at. And we have something called a Pythagorean triple. And that is a set of 3 positive integers that satisfy the equation a squared plus b squared equals c squared. Does anybody remember from way back in the day, like elementary school, what an integer is?
I can barely remember what happened.
Yes.
It's a number, a whole number.
It's a whole number, and usually integers can be both positive and negative. Whole numbers generally don't have negatives. Integers include the negatives. However, this one says it's the positive integers, which means we're looking at no decimals. Yay! Because we know how much we love them. Okay, so basically it's like 3 side lengths of a triangle that are perfect whole numbers that have no decimals. The most common one you see in life is the 3, 4, 5 triangle. If you ever see a triangle and one side's 3 and the other side's 4, the other one's going to be 5 if it's a right triangle. Okay? Another very common one we use a lot is 5, 12, 13, then 8, 15, 17, and 7, 24, 25. Okay? If you look at those 4 sets of numbers and then you look at the ones right below them, do you notice anything? It's just multiplied by 2. What if you look at the ones below that? Multiplied by 3. And if you look at the one below that? By 10. Yes.
Is there any way to calculate Pythagorean triples like by hand?
Not really. Not that I'm aware of. Okay. All right. So your Pythagorean triple, the first row there that I have underlined in red, those are like your prime Pythagorean triples, and then you can build Pythagorean triples on top of that. On yours, you'll notice it says 3 times x, 4 times x, and 5 times x. You can multiply 3, 4, and 5 by any other integer, and it'll make a Pythagorean triple, okay? Or you can multiply 5, 12, and 13 by any other number, and it'll make a Pythagorean triple. Same thing here and same thing here to get new Pythagorean triples. So if you're ever just looking for one, you can find them that way, okay? All right, that used to say the end. I don't know what happened. Now it just says the half of the, okay? All right, so you do have an exit ticket today, and I believe you have plenty of time to do it. So if you didn't turn in yesterday's geometric mean assignment, make sure you get that one turned in, because if I can't grade it, I have to give you a 0, okay?